In today's lesson, we are going to be reviewing some combinations. So this is just going to be a little bit of review of kind of the main things or concepts that we've looked at to prepare for our test. So first question. So Chester makes Mr. Lou 5 different types of cookies. He catches him coming out of the kitchen with crumbs on his face. How many combinations of cookies could Mr. Lou have eaten? So in this one, we are looking at, again, many different scenarios. We're looking at how many combinations could we have. It doesn't say specifically how many ways could I eat one cookie or two or three. So we could have many different combinations. So we could go through and actually calculate each type or each scenario, or we could look at this as looking at all distinct items because they're all different types of cookies. So we have two options for the first cookie. Either I eat it or I leave it and I don't eat it. Multiply by 2 again for the next cookie. 2, 2, 2, because I have 5 cookies, so 2 options for each. So this becomes 2 to the power of 5. And I'm going to subtract 1. And the reason I subtract 1 is because I'm taking away that null set. So I'm taking away that one scenario where I don't eat any cookies. And the reason is because I know that I've eaten one, right? I came out with crumbs on my face. So I know that I've eaten, or we know that I've eaten at least one. So I can't have that one scenario where none of them get eaten. Next question, in how many ways can a committee of 6 members form a subcommittee with at least one person on it? Right, so again, this is a similar scenario. Each person is different. They're distinct people. I don't care how or what order I choose them in or what order I pick them in. I just want to make a group. So because we're making a group, it's a combination. And because we're looking at all the scenarios with at least one, we could use, again, that kind of short form, right? 6 members. And they're either selected or not selected. So there's 2 options. So again, we would have 2 to the power of 6 minus 1. And again, we subtract the 1 because we have to have at least one person. So we can't have that null set, so we have to subtract or remove it. In the next one, so from a class of 30 students, 14 girls and 16 boys, how many ways can I choose a group of 5 students to be in charge of handing out and collecting supplies if there is at least one boy and one girl? So we have to look at all the different scenarios in this case. We've dealt with something similar in our lessons, and there's 2 ways to do this. We could look at the first way. If I have the first case, which is 1 boy or 4 girls. So this would be the same thing as saying 16 choose 1 times 14 choose 4. And I'm going to add it to the next case, which could be 2 boys and 3 girls. So 16 choose 2 times 14 choose 3. Plus the next case, 3 boys and 2 girls. So similar scenario, 16 choose 3 times 14 choose 2. And we continue it to the next one, which would be 4 boys and 1 girl. So 16 choose 4 times 14 choose 1. And we could add that up and find our final answer. Again, for sake of time, I'm not going to worry too much about that. Let's make this a little bit bigger. So that would be the direct method. The other method, or the indirect method, would be where we look at the total number of cases. So in this case, or the total number of scenarios, or the total number of options. And what we're doing in general is we're taking 30 students and we're choosing 5 of them. So that's our total. And we're going to subtract from the total the opposite case. So if we're looking for at least one boy and one girl, then the opposite case is we're looking for all boys. So we have 16 choose 5. We could say times 14 choose 0, but that's not really going to matter. We might as well show that anyways, just again, so we get used to having the idea of looking at the two components of our group. And we're going to subtract the other impossible scenario, which is all girls. So 16 choose 0 times 14 choose 5. And once we find our answer for here, these two answers that we find should be the same. Right? So we could use the direct or the indirect method for this scenario. The next question, a club has 10 members in it. How many different 4-member committees could the club form? So in this case, again, we're making a 4-member committee. So we have 10 choose 4, which equals 210. The next scenario, or the next question, looks at how many ways can a club president, vice president, treasurer, and secretary be chosen? So now this one is a little bit different. Now we're not so much concerned about how we can pick members for a group or how we can create the group. Now we're looking at for ways to select someone or ways to select positions. So in this case, we are looking at order. So we're looking at 10P4 in this case. So in this case, order matters. So that's the difference between the two. So this would equal 5,040. Now, question C is asking, by what factor do the answers in A and B differ, and why? Right, so how much larger is the one factor compared to the other? So if you look at the two, say 5,040 divided by 2010, and you get that it differs by 24. Where do we get this 24 from? Where do we see this, or where do we get this? And what we can do, and this is just a little bit looking at the factorial notation, if I look at the combination, 10 choose 4 is 10 factorial over 6 factorial divided by 4 factorial. When I look at the permutation is 10 factorial divided by 6 factorial. So the difference between the two is this 4 factorial, or that's the different factor. Right? So the 5,040 is 4 factorial times larger, or 24 times larger. So the difference between the two is just that 1 factorial, and that's because we're taking out the idea that the order matters when we calculate the combination. So again, it's just looking at the two different scenarios. In a euchre deck, there are how many 5-card hands could be dealt if there are no restrictions. So this is going to be a little bit different than maybe the assignment we looked at or had, because again, we want to make sure we're looking at the wording. So in this one, how many 5-card hands could be dealt? So we're focusing on the 5-card hands, not the ways to deal those 5 cards. So that is the difference between the two. So again, it's really really want to be careful in the wording and what we're looking for. So here we're looking for how many 5-card hands could we have in a euchre deck. Remember, a euchre deck is only 10 Jack, Queen, or not, sorry, 9, 10, Jack, Queen, King, and the ace of each suit. So if you're not familiar with the euchre deck, 9, 10, Jack, Queen, King, ace in each suit, and there are no restrictions. So if there's no restrictions, that means there are 24 cards, 6 cards per suit, so 24 choose 5. B, the hand must contain 3 clubs and 2 diamonds, or all hearts. So if I'm breaking it up into 2 parts, looking at the clubs, I have not 13, I have 6 clubs, and I'm choosing 3 of them. Multiplied by the second part, which is diamonds, I have 6 of them, choosing 2 of them. So that's the one scenario, plus the other scenario. So remember, or means plus. All hearts, so there's 6 hearts, choosing 5. So I'd add those 2 scenarios up. Final one, the hand must contain 4 face cards. So for face cards, I have 12 of them. Again, 3 per suit. So 12 face cards, choosing 4, multiplied by then the non-face cards. There's also 3 per suit, so 12, choose 1. So again, the main thing, we do have to make sure that we're looking at the 2 different components of our group, not just the one scenario or the one restriction, right? Yes, we're looking for 4 face cards, but we're also creating a 5-card hand, so we have to consider that that 5th card, not just the 4. So again, when you're looking at these types of combinations questions, you want to be careful with that. You want to make sure you're looking at both components. So again, this is just a brief overview of some of the concepts. You may want to review some other ones. Some other ones that we didn't really cover would be probability, some of the Pascal's triangle applications, or binomial expansion. So again, make sure you are going back and looking at the full textbook review and all of your lessons, not just focusing solely on the concepts in this lesson here. This is again just a little bit of a review, just to get you kind of thinking about some of the main concepts, but it is not all of the concepts.